ठीक है। Hello guys, I am Kshitij and I will be discussing string matching algorithms, pattern matching algorithms with you guys. Okay. So first of all, let me know if I am audible to all of you. So if you can hear me, just type yes. If you cannot hear me, just type no. Okay, cool. Cool. So we'll first start with a problem which involves concepts that have been taught in the previous classes by Vivek. Okay. So it's a problem based on a string, but the concept that you have to apply are already taught in the previous class. Okay. So just give me a minute. Okay, so we'll start with a basic problem. The problem says that you are given two strings s1 and s2. Okay, and you have to find out whether these two strings are isomorphic or not. Okay, and now what I mean by isomorphic is that if you replace each and every character of s1 by character of s2, you get a similar string. Okay, for example, if s1 is egg and s2 is egg, then if you replace a by e and d by g, then you will get a similar string. Okay, if s1 is foo and s2 is bar, okay, so this one is isomorphic, but this one is not. Why? Because if you replace f with b and then you replace o with a, okay, then you cannot replace o with r because o already has a value a. Okay, so just let me know if the question is clear to you guys. If it is not clear, just write your doubt. If it is clear, just write yes. Okay, cool. So take some time, try to solve this question uh, in the most optimal way possible. If you come up with an approach, just ping me in a private message. Okay, we can just let one of you discuss your approach as well. Yes, so there is a doubt, can the first character be replaced only by first name? Yes, so you have to keep the order in mind. So the index that you're replacing, that would be fixed. So the zeroth character can only be replaced by the zeroth character, then first character can only be replaced by first character, and so on. Okay. Okay. So some of you have figured out that you can involve hashing. Yes. Okay, so I think many of you have figured out that this is involves hashing. So Aditya, I will unmute you. Let us discuss how you will approach this problem. Okay. Yeah, Aditya. Oh, sorry. Yeah, Aditya, you are unmuted now.
So first we start from the beginning of the first string. We'll see what is the corresponding string with respect to that. For example, for A we have E. Okay, so we will just store it in an for A we have E, for D we have G.
Okay, so you are saying
First
that.
we'll see the
Okay, just give me a minute. Yeah, Aditya, you can continue now.
so for every character we'll see if there is some hash for it already. Okay, so if it doesn't have a hash already, we'll create a hash for that. For example, for A we didn't have hash, we'll hash it to E. For D we didn't have hash, we'll hash it to G. And
Okay,
for the
so
next time we get D, we'll find if it has a hash. Means if it already has hash, it's different from the one which we are getting. Then we know that they are not hash. Otherwise,
right.
they are.
So you are saying that you will have a map that will be from all the characters of S1 to S2, right?
Yes.
And in this map, whenever you get a character, you will check whether it is present or not. If it is present, then you will check this value, whether it is similar to the corresponding value in the second string, right?
Yes.
Okay. So you will be having only one map, right?
Yes.
Okay. But suppose if I have a case A, B, or say this is A, and okay, this is AB, and here I have AA. Okay, then your map will have something like A to B,
No.
right?
A to A. Because first character will
Yeah,
be.
first will be A to A, and then you will have B to A, right?
Um, yes.
But the problem is A is already matched with A. Okay, so it cannot be matched with any other character, right?
Yeah.
So you will have to change the approach a little bit, right?
Okay. Yes, we can use two maps then.
Okay, so you are saying that you will have a map 1, and you will also have a map 2, and what will this have?
String 2 and string 1.
Okay, so this will have string 2 to string 1. And whatever you were doing with only the first map, now you will also have to do with the second map also, right?
Yes.
Okay, cool. I think this will work, right?
Yeah.
Okay. So is there anyone who did not understood this approach? So basically what we are doing here is that we are creating two maps, map 1 and map 2. And in the first map, we are storing mappings from the characters of S1 to S2. And in the second map, we are creating mappings from S2 to S1. Okay. So whenever you encounter a new character, you will have to check it in the first map, okay, and then you check the corresponding character of the second string in the second map, okay. If it is present and it is same as that what you have encountered currently, then it's all good, and if it is not, then just return false, okay. So okay, is there anyone who has any doubt in this approach? No? If this is clear to you, just type yes. Okay, cool. So we'll now see some of the algorithms of pattern matching. Okay. So first of all, what is pattern matching? Okay, so pattern matching is where you are given a text, and this text could be very long. Okay, and you have to search for a pattern or a small string in that text. Okay, so suppose this is your text: A B X A B C A B C A B Y. This is your text, and it could be very long. And then you have a pattern, a very small string, which is say A, B, C, A, B, Y. Okay. So now you have to find the occurrence of this pattern in this text. Okay. Let us see how we will do it in a very conventional or naive way. Okay. Which is also called the brute force. So the brute force will check the first character of this pattern with the first character of the text. Okay. If this character is matched, then you will check for the second character, right? Then you check for the third character, and this does not match. So what you do is you start checking from the second character. Okay. Now again, you will check B with A, which doesn't match. So you will move this pointer to X. Now X also doesn't match with A, so you again move this, and now it comes on A. So now A matches with A, B matches with B, C also matches with C, A also matches with A, B also matches with B, but C does not match with Y. Okay, so what we do, we'll now start matching from B. Okay, now we'll check B with A, and it does not match, so we'll move this pointer to C, and this also does not match with A, so we'll move this pointer to A, where finally we will have a match. Okay. What is the time complexity of this approach? We are doing, say, the length of this string is M and the length of the text is N. Yes, so all of you are there with the answer. It's order N into N. Okay. Now, if you notice clearly, there are two things, right, which we can optimize in this approach, which could be optimized in this approach. What are these two things? First is, let us do it once again. I match A with A, then I match B with B, and then when I match C with X, it does not match, right? So instead of again starting the match from A and B, I already know that this string has been matched with this string, and these two are not equal. A and B are not equal. So I should not match A with B, right? So I can directly start matching with X. I can skip all the characters before that. Okay. So this is one thing. One more thing which you might have observed is that if we get a match, okay, so when we were matching till here, okay, so when we started matching from here, we had a match till A, B, C, A, B, right? And then we had no match at C. So now we know that this string is matching with this string, okay? We already know this information. And we also know that in our pattern, this AB here is repeating, right? This is a suffix as well as a prefix, right? And since these two strings were matched, this and this are same, right? Why? Because these two strings are match of each other. So these two are same. So let us say this is S1, this is S2, and this is S3. I know that S1 is equal to S3. Why? Because these strings are match of each other, and this S2 is also equal to S1. I can see that, right? So I know that S2 is now equal to S3, so I can just ignore this part and start matching from this C, right? So what I can do, I already know that this AB has been matched, this first AB has been matched with the last AB here. So I can ignore these two characters and I can start matching from C, right? So if we can fix these two things, what we can do is we can just improve this complexity from O of n into m to O of n plus m, okay, which is a huge improvement. So there were three guys, Morris and Pat. They did the same thing and they invented an algorithm which is called the KMP. Okay. Now we'll see how we can fix these two things in the KMP algorithm. Okay. So let us say our text is A, B, C, and A, B, C, D, and okay. So let us say this is our text, and this is the pattern that we want to find. Okay. So in KMP, what we'll do, we have to check whenever we get a mismatch, we have to check how many characters we can ignore. Okay. For that, we need to know that what is the length of string, substring in this pattern, which is a suffix as well as a prefix. Okay. Just like we saw here, we have a suffix AB and we have a prefix AB, so we can ignore this much, right? So let us see how KMP handles this. So what KMP does, it says you start matching from the first character. So A and A matches, then B and B matches, then C and C matches. And then there is a no match at D and N. Okay. So what you do in this string, we'll check is if there is string if there a substring which is suffix as well as a prefix. Okay. Uh, so examples of such strings could have been A, B, A. So in here, this is a suffix and this is also a prefix. Okay. But here there is no such thing. So this won't count and we will start matching from A and N. Okay. So we don't need to repeat this match again. We won't start from B. Why? Because there is no such match, right? So we'll start from N and A. So N and A do not match. Then we come to A. Now A matches with A. B also matches with B. C also matches with C. D also matches with D. Then A also matches and B also matches. Then we get a mismatch at C and M. So now we'll see in this string if there is a substring. Okay. Okay, some of you are not. Okay, I will repeat this once again. Okay, let's start from the beginning itself. First match A with A. Okay, now A matches with A, B matches with B, and C matches with C. But you have a mismatch at D and N. Okay, so now if you have a mismatch at this index, what you will do in the in this substring, you will check if there is a part which is suffix as well as prefix. Okay, what do I mean by that? Just like here. Okay, here the string was ABC. Okay, so this part AB is a suffix as well as a prefix. And why we are doing this? Because we know that we have a mismatch at Y, right? So that means that this whole string is matching with whatever is before Y. Okay, and if I get a similarity in suffix and prefix, so I can say that these two before whatever was before C was matching with whatever the substring I have here, right? Which is a suffix as well as a prefix. So I can ignore them, right? Instead of checking A with A and B with B, I can directly start with C. Okay. So the same thing will be done here. I'm just checking if there is a string, substring in this string, which is suffix as well as a prefix. Okay. If this C had been A, then we had this string of length 1, which was suffix as well as prefix, right? But this is not A, this is C. So we don't have this. Okay. So we will match A with N. Okay. So A and A also do not match. Then we again start with A and A match. Then A, B, B also matches. C also matches. D and we get a match till B, right? Now what happens? We get a mismatch at C and M. Okay. So what we do, we will check in this substring if there is a part which is suffix as well as a prefix. Okay. So we can see that this AB is suffix as well as a prefix. So we know that as we have matched this AB here before N, we do not need to match this first AB with this AB again. Okay. So what we can do, we can directly start matching C with M. Is this thing clear to everyone? If this is not clear, just write no or whatever your doubt is. Okay, Chandan, let me unmute you. Just tell me what is your doubt. Yeah, Chandan.
Sir, I could not understand means how how you are making prefix and suffix.
Okay, okay. I will explain this once again. Okay, and then tell me whether you're clear or not. Yeah. So what we are doing is I'm removing these things. Okay. So when I'm at this A, okay, I will match this A with this A, then this B, and I will get a match till here. Okay. Now I know that this whole string, this string is a match of this string, right? So these two strings are same. I know this. I also know that this part AB is same as this part AB. Okay. Right now, don't think how we are calculating whether this is same or not. Just see that this is clear, right? Right now we are just getting a visualization of this algorithm. Okay, so we'll see how to actually get it computationally. Okay, but right now just see that this AB and this AB are same, right? And we know that this string has been matched with this, so we have already matched AB here. Since we have matched AB here, we do not need to match this AB here. So we can directly start matching C with M. Is this more clear now? Or is there any other doubt? Okay. Anyone else who has a doubt till now? Okay, so we'll move on. So when I match C with M, what happens is this is a mismatch. Okay, so now I will again clear everything and we'll start matching A with M. Okay, so now I match A with M, it does not match. Then again we'll start A with A, it matches, B also matches, and then C also matches, D also matches, right? And then okay, we have removed then A from here, right? So then A also matches, and then B also matches, then C also matches, and then we have a mismatch here, right? So we have a match till C, and we get a mismatch at Y and D. Now what we do? Okay, so Manmohan is asking, shouldn't we start matching A with A instead of M? Okay, so Manmohan, what we did in the previous step was, we checked for only uh, this string, right? This suffix and prefix thing, we checked for this string and we got a mismatch of C and M, right? So we knew what we already knew was that this AB is matching with this AB, okay? But we did not know that whether this M is matching with this A or not, okay? So we will have to match this, okay? Good. So, okay, so now we have got a match till C, and here, okay, so Y and D don't match, and we get a match here. So now again, we'll do the same thing. We'll try to find out a substring in this string, which is suffix as well as a prefix. So we can see that this ABC here is both prefix as well as suffix, right? Which means that we have matched this ABC here with this one, so we don't need to match with the prefix one. So we'll directly match D with D, okay? And D matches with D, and then A matches with A, B matches with B, C matches with D, and we get a match, okay? So this is how KMP makes use of prefix and suffix for skipping the matched characters, okay? Is this clear to everyone? Okay, make sure this is clear to everyone. Just if you have any doubt, just write it now. Okay, cool. So we will move ahead. Okay, so now let us see how we can see efficiently about this string, whether we have a prefix or suffix. Okay, I will just unmute you, Satyasai, and just tell us your doubt. Yeah.
I understood the entire logic, sir. Can you just explain why is that skipping is actually giving us the right answer, sir? I mean, how can we prove that the non-skipping cases. There's no answer in the non-skipping cases.
Yes. Okay. So I will do that once again. So what is happening is, let us say you have a string here, okay, and at this place you get a mismatch, okay, and this part is completely matched with your pattern, and here is the y, okay. So these two don't move, and this part and this part are matched, right?
Yes. Yes.
Now I'm saying that since this part is matched, so let us say this is P1, P2, P3, and P4, okay, and this is A1, A2, A3, and A4. Okay. Since this part is
Yes.
matched, I can say that P3 is equal to A3 and P4 is equal to A4, right?
Yes, sir.
Now, if I know that this string and this string are same,
Yes, sir.
okay, which means that this is a suffix as well as a prefix. In that
Yes, sir.
condition, A1 will be equal to A3 and A2 will be equal to A4, right?
Yes, sir. Yes, sir.
So I have already matched, I can replace A3 and A4 by A1 and A2.
Yes, sir.
Okay, so this becomes A1 and this becomes A2.
Yes, sir.
So now I already know that I have matched these with A3 and A4.
Yes,
Okay,
sir.
and the same is here. So this has been matched with this,
Okay, sir.
and the same string is here. So
Yes, sir.
instead of matching it from here, A1, A2, A3, A4, okay, what I will do is I know that this A1 and A2 are matching already, so I won't match them. I will start matching with here A3 and this character.
Understood, sir.
Is it clear now?
Yes, sir.
Okay. So even if it is not very clear now, just after the class, go and take some cases, take some text, take some strings, and try to visualize it. Okay,
Yes, sir.
try to visualize that if you have a string here which is similar to a string which is prefix, then you can actually skip them, right? Because you have already matched them,
Yes,
right?
sir.
Okay, cool. So now we'll see how we can get the information about the prefix and suffix efficiently. Okay. So let us say our string is A B A B A. Okay. So KMP says before doing the matching, construct an array. Okay, of the size of this pattern string. Okay. So this is our pattern, and let's say its size is m and the size of the text is n. So KMP says that make an array of size m, okay, and in this array we'll store for each index I, will store the length of the longest substring, which is a prefix as well as a suffix. Okay, we'll get to know how. So this is your array. So each index of this array, so if I'm talking about this index, right, this value will give me the length of substring of this string, which is a suffix as well as a prefix. Okay, so is it clear to everyone what will be the value of this array, what this array will give us? Okay, we'll see in a more detailed way now. So for calculating that, we'll have two pointers. One will start from the 0th index and the other from the first index. Okay. Yes, then we can do this pre-computation using two pointers, and we will see how. Okay. So for a string of length 1, we assume that the length of the substring is 0, which is a prefix as well as a suffix, because we have only one string. So let's call it 0. Now we check string I and string j. Okay, if they are equal, then what does it mean? If these two are equal, that means that we have a substring of length j plus 1, okay, which is suffix as well as a prefix. Okay, so we'll fill here j plus 1, which is 1. Okay, and when we get a match, we'll increment both I and j. So I will move here and j will move here. Okay, now we'll check with a string of j and string of I, and they are not equal. Okay, when they are not equal, what we'll do, we'll check for whatever j is, we'll check the previous one. Okay, so if j is currently 1, so we'll check the previous value and we go to this index. Okay, now we'll see why we are doing this. We are doing this because first we had a and a, okay, till now. So we can see that we have a string of length 1, which is suffix as well as a prefix. Okay, then we get b. So here we match a with b. We were matching a with a b. Okay, so a matched with a, and then we were matching a and b. So this is a mismatch. So what we do, what we are trying to do now, we are matching b with a. Okay, so as if it is not of length 2, let us check whether it is of length 1. Okay, so for that we are now checking b with a. So j goes backward. Okay, so j comes here, and now we match b with a. It doesn't match, so it becomes 0. Whenever there is a mismatch, we'll only increment the I. Now the I goes here. Okay, Chandan, we will the same situation will come in future also in the next character. So we'll look at there, okay, in detail. So now you match a with a, okay, and it matches, so it becomes j plus 1, which is 1. Keep visualizing it, okay. So currently we have a, and the length of the longest substring, which is a prefix as well as a suffix, should be 1, which is a, right? And we have 1 here. Okay, so always whenever we are filling a value in the cell, just try to check for that substring, is it correct or not? Okay, so since we get a match, what we'll do, we'll increment both I and j. So I comes here and j comes here. Now a and a are again matched, so we'll do it j plus 1, which is 2. Okay, so as you can see, if I get another a here, this and this, these two will match, so it will be of length 2. Now we increment I and j both. Okay, so I comes here and j comes here. B and B also matches, so we get a 3 here. Then again we'll increment both I and j. Now a and a will again match, and we'll get a 4 here. Okay, then again we'll increment I and j. So again a and a will match, and we'll get a 5 here. Now again we will increment I and j. C. So the same situation has arrived again. Okay, so now we have a and b, and they do not match. Okay, so till now what we know that we have a string of length 5, okay, which is till now, till here, we have a string of length 5, 1, 2, 3, 4, 5, which is a suffix as well as a prefix. So this string AABAA is a prefix as well as AABAA. This is as well as a suffix. Okay, and we were trying to check whether this could be of length 6. Can we increase this till here and this till here? But we got a mismatch, so we cannot do that. Okay, so now what we will try is, we know that this AA is already present here, right? So now we will try to check whether this A can be matched with this B. Okay, so for that, the J goes to the previous position, okay, which is 2. So we now check, and why it is going to the previous position, because in this substring we know that this part is repeating of length 2, right? So whatever part is repeating, we'll go and check for that. Can we extend that part using this A? Okay. So now this J goes to the previous, and whatever value is here, we'll go to that index. So we go to B, and it does not match with B. So then what we do? We go to the index which is here, okay, and which is 0, right? Is it clear to everyone? If you have any doubt, just write now and we will do it again. Yeah, we go to Tanmay, you are right, we go to that one only. Yeah, we'll do this again and just erasing everything. Okay, so let us fill this again, and in the process we'll revisit that thing again. Okay, so first the J is here, I is here, okay, and this is 0. These two do not match, these two do match, so we get a 1 here. Okay, and then J and I both are incremented, and this becomes 0. For now, let us just assume that this is 0, and we will see that part in the bigger example which will come in the next step. Okay, now we increment I, so I comes here. Okay, no, wait. Yeah, so when we were here, this was J and this was I. What we were doing is we had A and we got a match here, right? Now B comes, so we are checking AA with AB. Since this is not matching, we'll try to check B with A. Okay, so this J becomes 0. So this J goes to 0. And now we will check these two. They two do not match. So we get a 0 here, and we increment I. Then these two match, so this becomes 1. Then these two also match, so this becomes 2. These two also match, so this becomes 3. This is also matching, so this becomes 4. This is also matching, so this becomes 5. Okay. Now what happens is we are we have covered till here. Okay, and we have a string of length 5 starting from 0, which is a prefix as well as a suffix. Okay, this is clear to everyone, right? If we have 5 here, that means that we have a string which is of length 5, which is a suffix as well as a prefix. Okay, now we were trying to extend it till length 6. So we were trying to check, can we do it till here and can we do it till here? Okay, but there is a mismatch between A and B. Okay, so what we'll do is we will now check it. Okay, in this string, the first part here, we know that for this string the maximum length is 2, right, which is AA here and here, right? So now we'll try to go back and check it whether it matches with this part, right? So since it was matching here, right, we want and this is a prefix, so it has to be at the beginning of the string. We'll go back and check whether it is matching with the prefix of this string which has A. Okay, so we'll go back to the J-1 index, Okay, so yeah, we'll go to the where is our current j? Current j was here, right? This was our current j. So what we'll do, we'll go to index number 2. Sorry, current j was here, right? That's why we have, yeah. So our current j is here. Okay. Now we know that in this string we have a substring of length 1. Okay, so we'll go to here and we know that this is of length 1, so that means we can check this a with the character at after that one length character. Okay, so if I give you another example, say this is the string which is, okay, let us see it here only. See, these 5 and these 5, they are matching. Okay, current j is here and I is here, but we are not able to extend it till here. Okay, so now what I want is, can I have another suffix including this? Okay, now we will ignore this whole 5 length thing and we will try for a smaller one. Okay, so in this string we know that these a's and these a were matching, right? And since we had a mismatch here at this position, we'll check for this string. Okay, so in this string we know that this a and this a are matching. Okay, and uh, this string has been matched in this string, so that means whatever is in front of this a has matched with whatever is in front of this a. Is it a little bit clear, more clear now, what we are trying to do here? If it is not, just write no. Okay, okay, okay. Uh, did you guys understood what was happening here? Yes. Anyone who is not clear with what was going on here? Okay, so now just assume that this A is not A, this is S1, this is S2, and we have C1 here. Okay, let us understand, try to understand in this way. Okay, so what we were trying to do is we matched S1 with S2 and we got a match. Okay, now when C1 comes, so we'll try to have something of from here to here. So if this is S1, this is S2 and this is C. Okay, and these two were complete match. Okay, now when we get C, since we have to find this a suffix, so we will have to include the C at the end, right? So we'll try to find whether we get something here of this size, okay, which is same. So we want to now check this thing, which will start from the starting of S1 and will have end something on somewhere on S2. Okay, and it will, and the second one will start from S2 somewhere on S2 and will end on C1. Okay, the same thing, right? Now if this and this, they do not match, then what happens? We know that it has been matched till here, right? This portion has been matched with this portion, right? And this portion is also same as this. Okay, whatever length, it might be 0 or some whatever it be, that much length, whatever value we have, that much length is similar to this. Okay, and we have already matched this with this, right? So what we can do is we can directly check this value with something here. Okay, does it make sense now? Okay, so the same thing is going on here. Okay, we are going back because we know that for the string removing that character where we got a mismatch, the value at this position, it gives us this substring starting from the front, starting from the 0th character, which is suffix as well as prefix, right? So we will then try to add our mismatched character in that substring. Okay, so this thing, similar thing is going on here. Is there anyone who is still not clear? Just tell me, I will try to explain in some other way also. Is there anyone? No? So can I assume that this thing is clear to every one of you? Just write yes if you are clear. Okay, okay, cool. So, yeah. So now what happens here is, since we went to, from here, we went to index 1, and we'll check it with this A and this A and this A matches. So we'll get whatever is this value, J plus 1. So it will become 2. Okay. And now you can actually see that this index gives us 2. So this means that this should be present in the front as well, which is actually there, right? So hello. Yeah. So this is what KMP is, okay? Like what your LPS is. And now we'll see how we can use this array to do the string matching, okay? To do the pattern setting. So we'll take another example, okay? Let's say your example is again the same that we took for the matching example. This is your text and the pattern is A, B, C, A, B, Y, okay? So first we'll compute the LPS for this. LPS means longest prefix suffix array. Okay, so again we'll have 2 pointers, one is J, one is I, and we'll initialize the 0th position with 0. Now J and I, they do not match, so we get a 0 and we increment the I. Then A and C again do not match, we get another 0. We again increment the I. Then A and A match, so we get a 1 here. And then we increment both I and J. Okay. Now B and B also match, so we get J plus 1, which is 2. Okay. And again increment I and J. Now they do not match, so J goes to J minus 1, and at J minus 1 we have 0, so J becomes 0. Right? So this J comes here, and Y and I again don't match, so we get a 0 here. So this is the LPS of this string. What it tells it tells that at every position I, so if we are talking about this position, till here we have a string of length 2, which is suffix as well as prefix. Okay, so if we have a match till here, we can ignore a length of 2 from the front, right? We'll see how we'll do that. Okay, yeah. So now we'll start the matching. First we match A with A, then we match B with B, then we match C, and it gets unmatched. Okay, so there is no match here. So what we do is, we can check in this string AB if there is, what is the length of the string which we can skip. So it is 0. If it is 0, then we have to match X from A. Okay. So now we match X with A, it doesn't match. We now match A with A, it matches. Then B also matches, C also matches, A also matches, and B also matches. So we get a match of this much length. Okay. And then we get a mismatch at Y and C. Now what happens, we'll see in this string from A to B, what is the length of this string, which is suffix as well as prefix. So it comes out to be 2. So we'll directly start matching the second index. Why? Because length 2 has already been matched here, right? So we can directly start matching with the second index. So this will match the C with C, and then A with A, and we get the pattern. Is the matching part clear to you guys? If it is not, okay, cool. So this is your KMP. Okay, it had 2 steps. One was creating your LPS of the pattern, and then you were doing the matching. Okay, so creating LPS takes you order M time, where M is the length of the pattern, and matching will take you order N time, where N is the length of the text. Why order N? Because we are never going back. Okay, like in the brute force, we did a match and then we again started the match from the next index. Here we are never going back. We are always moving forward. Okay, so the time complexity of KMP will be order of M plus N. Okay, and will also take order M space. Okay. LPS full form is longest prefix suffix. Okay. You can also call it simply auxiliary array. Okay. Pre-processing array. The name doesn't matter. So just don't worry about the name of full form. But if you're asking, it's called longest prefix suffix. Okay. So now do practice this algorithm on some text and strings. Okay. Do not try to memorize how to compute LPS. Okay. Do not. If you try to memorize how to move the pointers and how to go back, there are very high chances that you will forget it after 3-4 days. Okay, so try to get a feel, actually use strings and try to build this array for some strings, for 10-20 strings, and you will yourself start getting the feeling of why we go to backward and how the suffix and prefix is playing there. Okay, please do not try to memorize how to compute LPS. Okay, just learn it from practicing and visualization. Okay, so should I assume that every one of you is now clear with KMP? Okay, so we will move forward and we will now solve a question which was asked in Google. Okay, so the question is that you are given a string. Okay, say the string is E, D, E, F, and you have to return the number of characters that you can add in front of this string to make it a palindrome. Okay, so suppose this is your string, and if I add F in front of this string, this will become a palindrome, right? So is the question clear to everyone? If the question is not clear, just write no. If the question is clear, just write yes. Okay, so I will repeat the question once again. Yes, you have to find the minimum number of characters. That was a very essential point. Okay, you have to find the minimum number of characters that you can add in front of. Okay, so there are 2 points to take notice. One is the minimum number of characters, and second is that you can add in the front. Okay, so this is add in front. Okay, so you have to find minimum number of characters that you can add in front of this string to make it a palindrome. Okay, we can have some more examples. If suppose the string is A, B, B, and then if you add B here and another B here, okay, now it becomes a palindrome. So the answer for this should be 2. Okay, so time complexity should be order of n. You can use extra memory if you want, but just tell how many. Yes, so if you have any approach, just ping me in private chat. Don't spoil it for others. Okay. Yes, Tanmay, you are right. You are going in the right direction. Okay. Just make your approach more clear and try to run it on some cases. Yes, Nikhil, your approach is right, but the thing is how to do that. Yes, Subhash, you are in the right direction. Ashish, rethink about the time complexity of your approach. Okay, take some more cases and try to run on them. Rahul, your approach is also correct, but again, the question is how to find that. Abhishek, I think you are in the right direction. Okay, so I'm giving you 1 more minute. Everyone who is coming up with an approach, just ping me. Then we'll discuss one of your approaches. Satyajit, I think you are in the right direction. Just think about some cases. Santosh, just think about the time complexity of your approach. Take some cases with repetition of characters. Okay, so okay, I will unmute Tanmay. Okay, Tanmay, let us talk about your approach. Many of you are giving similar approaches using LPS. So, Tanmay, you can talk about your approach.
So I was thinking along that line that in LPS array we have that there is a suffix which is also a prefix. So
Right.
basically, we get a palindrome already. So there is some palindrome hidden in that.
So let us talk about this example only. You have E, D, E, F, right? Now, how you do that?
Yeah, so if they start calculating this LPS array
Okay.
for 0, 0, 0,
0, 0, 1.
and yeah. So I was saying that ED is already a palindrome we see.
ED is already a palindrome.
Yeah. So that is, I was thinking that maybe we find the first non-zero character in the LPS array.
Okay, in that
I'm
case,
not sure about, but yeah, there will be some logic along that line.
okay. Okay, let us see. Okay, so Satyajit has a test case for you, E, D, G, E, F, where he's saying it will fail. Just try to run it for this test case.
Okay.
Right?
Yeah. 0, 0, 0.
Okay, so all of you are trying to calculate the LPS for the given string. Okay, all of the approaches that I have are along the line that calculate the LPS for the given string, and then using some of the value, I try to find whether it is a palindrome or not. But the thing is, LPS gives you the length of string, which is suffix as well as prefix. Okay, it is not in reverse order, right? So if I say ABC and then ABC, this is not a palindrome, but you will get a length 3 substring which is suffix as well as prefix. Okay, so this is not a palindrome, but you will, the answer here will be 3 of your LPS because there is a string of length 3, right? Mukesh, your approach is correct, but the question is how to find the largest palindrome, right? Rupesh, again calculating the LPS. Okay, Rupesh, I will unmute you. Let us talk about your approach also, and then we'll see the solution.
Uh, Actually, if the string is palindrome, then the last element will always be the length of the string.
If the string is palindrome, then the last element will be
Last element in the LPS array will be the length of the string.
yes. So, if the string is palindrome, say A, we have this as A B C B A.
Yeah.
Then you are saying the last element in the LPS should be equal to
Length of the string.
um,
No.
no, it will be 1, right?
Yeah.
Okay, so let's see the solution now. I have given enough time. Okay, so what does your LPS tells you? The LPS tells you that at any index I, what is the length of the substring which is a prefix as well as a suffix. Okay, and now every one of you are clear till now that for this question you have to find the length of the palindrome starting from the first character, right? If you get the largest palindrome starting from the 0th character, then you can add the remaining characters to the front, right? If you have E, D, E, F, then you just start from 0 and find the largest palindrome which is of length 3, then you can just reverse the remaining characters and place them here. So it will become a palindrome. Right, now the question is how to find the largest palindrome in order n. So if I append the reverse of this string, yes, then I guess you are on the correct path. If you append this is concatenate the reverse of this same string here. Okay, so if I have E, D, E, F, and then I use some character which is not present in the string just for partitioning, and then I append the reverse of this string here, and then if I calculate the LPA, okay, so this LPA, if suppose I get a length 3 here, okay, so if I have EDE here and EDA here, so I will get a substring of length 3 which is a suffix as well as a prefix, right? This tells me that since this string is formed by reversing the original string, okay, that means that if this S1 and S2 are equal, okay, if I say that S1 is and S2 are equal, then I can say that this string S1 and S2 is a palindrome, right? Why? Because I am just saying, say this was the string ABC, ABC, here the suffix and prefix are ABC, ABC, okay. Now had this ABC been CBA, this would have been a palindrome, right? If this had been like this was a palindrome. So what we are doing here is we are just reversing this part, okay, and then computing the LPS. So the LPS comes out to be 3. That means starting from the 0th character, we have a palindrome of length 3. Is it clear? Anyone who is not clear with the logic? Yes, Manmohan. I will just unmute you. Let us see what is your doubt. Okay, many of you must be having same doubt. Oh, you are clear. Okay. Anyone who is not clear, just let me know. Anyone here who is not clear with the logic? So should I assume that every one of you is clear? If you are clear, just write yes. Yeah, you can ask that in the last. Okay, cool. So I'm assuming that everyone is clear. Okay, and for those of you who are not clear, I will just repeat this part that I'm appending the reverse of this string, and then I am finding the LPS. Okay, then at the last index of the LPS, I will get the longest palindrome starting from the 0th character. Why? Because I have appended the same string in reverse order here, and if I get a match this with this, that means that these two are equal, and this is also in reverse order, so this means that this is palindrome, right? If I say that S1 is equal to S2 and S2 is reverse of S1, so this means that S1 is reverse of S1, right? Which means that S1 is a palindrome. So the solution would be find the length of the longest palindrome and then subtract that length by the length of the string. Okay, then you get the number of characters that you can append in front of the string to make it a palindrome. Okay, cool. So we'll move on to the next thing. Okay. Okay, let me know generally at what time the class is closed. Okay, because this might actually get extended till 11:30 or 11. Okay, so your class is finished till 10 always. Okay, okay, good. So we'll end this session here, and before this session, we have a poll for you. Okay, let me just. Okay, so we'll end this session here, but do one thing after the class, just read about KMP, okay, and take some examples and try to build the LPS and then try to match the pattern there, okay. If you don't do that, you will forget it, okay, and if you forget it, you won't be able to implement it. So first go take some strings and try to build the LPS, try to match, and when you get a feel, you are able to visualize the things, then you go to the code and then you write the code for LPS for the KMP. Yeah, remaining questions will be covered in the next session. I'm just creating the poll. So in next 2 3 days, we'll study different algorithms, right? So the question will be general. So they will be based on all the things. They will be general. So if you are able to solve the questions from today, you can do that. If you are not, then just wait for the next class and then try to solve those questions, okay. But some questions are very general string questions, like adding two numbers represented in a string, or something related to manipulation of string or changing strings, reversing strings. To do solve those questions, okay. If you find any question which is based on uh, things not taught to you, then you can skip that and wait for the next class, okay. So, so we have two polls. Sorry, I think. Okay, let us just do it. Oh, yeah, I got it. Okay, so the poll, I don't think the poll is created. So I'll ask the question here only, okay, and if your reply is no, okay, then only you answer, okay. So first thing is, do you guys have an exam on Wednesday, 15th? If you don't have, just write no. Okay. All of you, please answer this question. It might be practical or anything, but is it there or not? Okay. Okay. And so this answer first question. Oops, sorry. And another question is that Vivek has been teaching you on whiteboard, right? This I took a class on iPad. So do you guys like the experience on whiteboard or iPad? And I am talking only about the experience, okay, not the content or the tutor. Okay. Okay, so seems like most of you like whiteboard. Okay. Okay, cool. So, yeah, the right light reflection is to be sorted there, and okay, we are working on it, and the light thing will be fixed, and the audio will also be fixed. Okay. Yeah, right. Okay, so I think we can end our session now. Uh, okay, so any of you who want to get this explained again? Any of you? Okay, so I will explain the LPS again. Okay, and if you think that you have already understood it, then you can leave the class. Okay, but if you want to have a look at it again, then you can stay. Okay, so I'm taking the same example. Okay, let us say we have A, B, A, A, B, A. Okay, so we'll first write the index here. Okay. So here I and j are just 2 pointers. What we have to do is, see, we have to find a substring. If I'm talking about this much of a string, okay, I have to find a substring starting from here. Okay, this will be my prefix, and one string which will end here. Okay, so I have to find two strings. One will start here and one will end here. This will be my prefix. This will be my suffix. I want to find the length of the longest such string. Okay. Yes, we will look into this. Okay. So what I want to have, I can do it by using 2 pointers. One will start from here and the other one will start from the first index. Okay, and I will match them. So by default, I will say that the LPS of the 0th index is 0. Why is it 0? Because if we get a mismatch here, then we will have to again match from the same index. Okay, we cannot skip any character. That's why it is 0. Now I match these two, and so assume that the string is only this much, AA. Okay, so what I'm doing, I'm just matching these two characters. Okay, this is a valid point. Okay, cool. So let us now continue with the algorithm. Instead of speaking this and that, I will actually say the thing. Okay. So what happens is so consider the string is A and A. Okay, only this much. So I am comparing the first A with the last A, right? So I get a match and I put 1 here. Why 1? Because I have got a substring of length 1, which is prefix as well as suffix. Okay, so I put 1 here. Now what I do, suppose this string was of length 3. Okay, so now I have matched these two characters Okay, so I've got a substring of length 1 for this much of string. Okay, now I would like to check for a string of length 2 whether I have a substring of length 2 which is a suffix as well as a prefix. So this is already matched, right? So now I will match this B with the first A. Okay, and it does not match, right? So I will write 0 here. Are you clear till now? Manmohan, are you clear till now? Okay. So now our I is at A and J is also at A in the 0th position. So currently I have A, B, A, right? And now I need to compare the first A with the last A. Okay. Why are we doing this? Because we know that in the first three characters in the AAB substring, we don't have a substring of length 2. Okay, that is why we are checking this last A with the first A. Okay, if say this was not B and this was A, okay, just assume that this B was A instead, then what would have happened? Okay, we'll start from the beginning. So here this would have remained same. Now when this third A comes, we have a string A, right? And we already know that these two are matching, right? So now we will match this A with this A, means the second A with the third A to get a match of AA with AA. This string AA with the second and third A, this string. And we will get a match, right? So this one, instead of being a 0, in the second index, we would be having 2, right? Then if you had another A, then what would happen? Now you have in the first three, in the substring except the new A, you have a substring of length 2 which is suffix as well as prefix, okay, and that substring is AA. So you have an AA in the beginning and then you have an AA at the end as well. Now you would have tried to check whether you can get a substring of length 3 or not, okay. So if you are able to get a substring of length 3, AAA and then AAA, okay, then you are sorted. Okay, then you will just write here 3. But if that is not possible, and that will be not possible if this A is not A and if A is B. In that case, the matching in the for the 3 length string will fail, right? And then when the new A comes, you cannot match the new A for a length greater than 2. Okay, so you will match this new A with the first A. Same thing is going on here. So what happens is when you have done till index 2, now when the A at index 3 comes, then what you do is you match this A with the starting A. And then you get 1 here. Now again we will do the same thing. We will increment both J and I. Okay, so J becomes here and I comes here. Okay, why we did this? We did this because in the string AABA, I have a substring of length 1, right? So now when the next A comes, then I will try to check whether I can make this length of 1 a length of 2. Okay, so since I already know that in this 4 length string I have the first and the last A matching, then I will check the new A with the second A directly. Okay, if this matches, then I will have a substring of length 2 which is suffix as well as prefix, right? If this does not match, then I will have to check the last A with the first A, right? And then the length of my substring, which is suffix as well as prefix, will be 1. Okay. So what is happening in this case? Here, this A, which is at I position, matches with A, which is at Z position, J position. So we get 2 here. Okay. Is everyone clear till now? Right. If it doesn't match, so the same thing, I just said the same thing, that if this A, if the new A, okay, so we have A, B, A till now, and we have a new A. Okay, so now we are trying to match this new A to make a length of 2. Okay, if this A does not match with this A, okay, then we will match this A with the first A. Okay, we know that we cannot make a length 2 substring. Then let us try to make a length 1 substring. Okay, so what we do, we match this A with the first A, but in this case it is not happening, so the A's are matching. So we'll see afterwards, we'll get such condition, right? So we'll just delete these things. Okay, so when when we get a match, then what we do, we just increment both the pointers. Okay, so we can see whether the next 2 characters are matching or not. So what is going on here is I have A, B, A till now. Okay, and I have a substring of length 2, which is suffix as well as prefix. Now a B comes. Okay, so I already know that this AA at the end is matching with this AA at the back, at the front. So I can skip this match and I can directly match this B with this B, right? So I'm doing the same thing here. I'm matching this B with this B. If it matches, then the length will be increased to 3. Then I have a 3 length substring. Okay, and if it does not match, then what will happen? Then I will try to check it in this string, in the first, in the string that is before B. Okay, so I will then try to fix this B somewhere here, whether it can extend the length present here. Okay, we'll see how. So currently they do match, so we get a 3 here. Now I have a string of length 3, which is suffix as well as a prefix. Okay, now what happens, we will again increment both I and J. Okay, now again same thing happens, I get an A. Okay, so I will again write down the same thing so that you can visualize what is going on. I have A, B, A. Okay, and A, and also B, right? So currently I have this much of string of length 6, and here I have a substring of length 3, right? Which is a prefix as well as a suffix. Now a new A comes. Okay, so I will try to extend this 3 length string to 4 length. Okay, I will try to check whether I can get a match of length 4. So these 3 are already matching with the suffix 3. So I will try to extend these 3 to these 4. Okay, so now my suffix string becomes A. Okay, and now I will try to match this string with the string forming by adding the new A, which is A. So this A will be matched directly with this A, the A in between. So the last A will be matched with the A after our suffix string, after our prefix string. Okay, and this matches, so the count will increase. And if it was not matched, okay, then we will see in the string before the A. So in our prefix string, we will try to see if we can get a longer match using the new A. Okay. Now what happens? This becomes 4. Okay, at index 6 we get a 4. Again, we'll increment both I and j. Okay. Now we will match A and A at I and A at j. And same thing will happen. We'll try to increase the length from 4 to 5. Okay. So since A and A will match, the length will be increased to 5. Okay. Now again we will increment both j as well as I. Okay. Now we get a mismatch. Okay. So again try to find out what just happened there. So we have till index 7, we have done till here, right? And till here we have A, B, A, B, A, right? And a string of length 5 from here 1, 2, 3, 4, 5. This suffix is matching a prefix which starts from 0, 1, 2, 3, 4, 5. Okay. So now you can see that in our new string, like the string till now, we have a match of length 5, right? So the first 5 characters are matching to the last 5 characters. Now a new A comes, okay? So what will happen is we will try to extend this match of length 5 to length 6, okay? We'll try for that. So for that, we will try to match this A with this B, okay? Now this do not match, okay? So there is no match between A and B. So then we will see in this string, in the prefix string, okay, whether we have a substring which could be extended using the new A. What it means is that in this substring, okay, let us see this here in the original array. If my j is sent back to the index where is sent back to the previous index, okay, so currently the j is here, so I will send it to the previous index which is 3, right? So now j comes here and okay, try to understand in a way that in this string, in the prefix string, the LPS, we already have the LPS for this string also, right? So the number that is here, present here, this for this string, it will give me the match, the longest substring till here, which is prefix as well as suffix, okay? And if I am able to add this A there, okay, if I am able to get a string with a match here, then also this will come to use, right? Just like we saw here in this case. Please mute yourself if you don't want to say anything. Okay. So now what is going on is we have a string, okay, till which is from beginning till mid, and then we have another string s2 from here to here, and the new character is here, and we want to extend the match, but we are unable to do it. Okay, so now we already know that in this string, the prefix string, okay, which is in this case we have a. We already know that this AB, the suffix AB, is a match with the prefix AB, right? So we'll try to match the A in this string, okay? So let's see if this gets matched, but because if this is matched with this A, then we'll have a string of length 2 here, right, which will match with this string. Why we are going back is because we know that it is not matching with here, it is not matching here, so we are comparing it with, we are trying to get a match out of the prefix string, and in the prefix string also we know which part is matching with the prefix part. Okay, so we can get that information from our LPS, and we can then check it, check the new A with whatever length we get. So suppose if we get 1 there, so we'll check it with 1. Okay, if we get 0 here, we'll check it with index 0. Okay, is this clear why we are going back? Okay, I will again show you the S1, S2 thing. So yeah, this is the thing. Here what is going on is you have a string S1, okay, which is this string, and you have a string S2, which is this, and these two are match of each other. Okay, so this is a prefix which is a suffix as well, and now a new character comes here. So you will want to extend this S1 to the length of this. So you will want to extend the length by 1. Okay, so this you will try to match this character here with the new character. So the first character of S2 will actually be matched with the new character, right? And if this is a mismatch, then you know that in your string S1 you had a match for this character, right? Since S1 and S2 are match of each other, you had a match of S1 in you had a match of first character of S20 in S1. Okay, and you know that S10 is already a match of S20, right? This is clear, but you can check that by using the fact that this string also has a substring which is a prefix as well as suffix. Okay, so you got it, right? Anyone who has not understood this? Everyone is able to grasp why we are going back? See, in the first go, it might seem complicated, or it might be very unintuitive, right? But when you actually do practice, when you actually make the LPS array yourself, keeping the strings in mind. Okay, so this is your homework. Just create the LPS array and just don't move the pointers. Okay, don't only move the pointers, also write it down. Okay, also write the substring that you are getting and the new character that you are getting, and then see what is actually going on there. Okay, then only you will get the exact feel of it, and then you will never forget it. Okay, if you try to remember how the pointers are moved and then you don't practice it, then there are very high chances that you will forget the things. Okay, so just go back, take some strings and try to take different kinds of string. Okay, with repetition, without repetition, okay, with 2-3 characters repetition, etc., and try to build the array. Okay, and see what is going on there. Okay, and try to do that, and if it is not clear even then we can again revisit it. Okay, cool. So I will end the session now. Okay, just try to solve the questions in the assignment. Okay.